Hello viewers. In this video, I'm intending to talk about the Unix standardization process. In a previous video, I discussed about the history of Unix and the Linux operating systems and how it panned out over the years. So in this video, let's look at Unix standardization process leading up to the Linux and what kind of standards that it conforms to and so forth. Right. So what was standardized in the past? So if you look at the Unix operating system, if you had looked at my previous video, you would have known that there have been various different kinds of Unix distributions um, became available during the 80s. So this led to various different types of standardization or rather various different types of implementation and header files, and it became increasingly difficult for applications to be ported across various different operating systems. So with the standardization process, what was intended was to standardize the Unix programming interface, or simply the APIs, uh, which is essentially the C API, because Unix was at the time, predominantly implemented using the C programming language, and then it was the shell. If you know Bash shell, Bourne shell, C shell, Corn shell type of shells, if you have heard of how things work with the shell and how it should interact with the kernel and the system calls, were also standardized, and that's what they call as shell standardization. And then Unix utilities, and there were so many different kinds of utilities that came to light during the 80s and then also in the 90s. So they had to standardize those utilities as well. And then system administration related procedures and tools were also standardized, and it was under development, and it was never widely followed as a standardization mechanism because that was not as crucial or critical as the programming interface or the shell interface or the Unix utilities. So these were the things that were standardized. So let's look at what led to standardization. So I already touched on the fact that during the 80s there were many Unix variants were available, and some were based on the BSD variant and some were based on the System 5 variant. System 5 is from the original Unix developer AT&T, and the BSD variant is coming from the University of California, Berkeley software distribution. But BSD is such an important facet in Unix development because it brought in various important development, such as the networking API and so forth, which was very, very crucial for the modern Unix and Linux as well functionalities. And so you cannot deny the fact of how important BSD had been during the 80s. So writing application that run across all different kinds of variants became a great difficulty, and even there were various other distributions that followed the BSD path, and various different kinds of distributions came to light, like the Sun OS, HP, AIX, and so forth, right? So if you want to know about what the history has been, and I will have a link to my previous video as well, have a look at that as well, and to know how the history of the Unix and Linux had been. So this drove to a very strong need for standardization of the C programming language as well as the Unix system. Right, so then let's quickly look at the C programming language and what was standardized at the time. So during the mid 80s, and there were minor differences on various Unix implementations, including what the C compiler constituted, right? And if you have a C programming background, it's highly possible that you would have heard of this Kernighan and Ritchie book, popularly known as K&R book. And it didn't, in the initial release of that book, the first edition of that book did not detail a standard, because there wasn't a standard. And the language that it detailed is usually called traditional C, or it is also called as KNRC. But was the need for the standardization became paramount during the 80s, actually the latter part of 80s, and the standardization process began at the latter part and then finally became to light in 1989, and it was then known as NCC, and it was also known as C89, and or in the real world CX3 15998 1989. So those are the code names that standardization followed and so forth. And it became an ISO standard in 1990. So the 1989 was not an ISO standard, but it became an ISO standard in 1990. And that particular version is called ISO IEC 9899 colon 1990. And this is also known as NCC. This was also known as NCC, popularly known as C89, and then less commonly known as ISO C90. And the standardization, actually, what it actually standardized out of the C programming language was the C standard library and other functions like the stdio functions, the string manipulation functions, and so forth. And anyhow, the second version of Kernighan and Ritchie's the C programming language book, which is a very short book, it's a very small book, outlined the standard C, which was the C89. And C then prevailed for a very long time, that particular standard, and then the second standard was ratified in 1999, which is popularly known as C99. And then in 2011, along with C++11, the C standard was also modified to C11, and then C++ went on another standard called C++14, and then C++17, but C didn't have another standard in between. It just right away came to C17, and then again C++ had something called C++20, and now C++23 is the latest standard, and along with that you also have C23 standard, which actually adopts somewhat C++ style notions into the C23 standard as well. So that aside, C is a great language which is still being used, and drivers are developed, kernel is of course developed in C, Linux kernel, and so forth. So you should keep an eye on various standards if you are interested in that side. So let's come into this notion called the POSIX standard. If you have heard of this word POSIX, that stands for Portable Operating System Interface. So this is one of the efforts that try to bring a standard to the Unix operating system especially. And POSIX name was coined by Richard Stallman, the person behind the Free Software Foundation. And the first POSIX standard was referred to as POSIX.1, and it was also known as POSIX 1003.1, and it was ratified in 1988 as an IEEE standard. And it was an API for set of services that a conformant operating system should support, and for the problem that various different Unix variants try to follow different kinds of APIs and so forth, which made porting applications across Unix variants difficult, and that's what POSIX tried to solve at the time. And it was basically based on the Unix system calls and the C library functions, and that itself became an ISO standard in 1990, which is known as ISO IEC 9945 1990. And then various other extensions were brought in, or modifications. So notable ones are the POSIX 1003.1b, also known as POSIX.1b, which is also known as POSIX.4 and POSIX 1003.4. These names is irrelevant. It's not of a great interest for you to know, but for you to appreciate the literature, you should know about that. And those extensions had real-time extensions in 1993. So what is the real-time extension means is like the file synchronization mechanisms, asynchronous I/O, and process scheduling, inter-process communication using semaphores, shared memory and message queues within the operating system or within the system interface. And that could work between different processes and so forth. Now, things like asynchronous I/O that you hear today as great stuff had been around 1990s and even before. And we should appreciate the fact that these great individuals who had worked on these things are sometimes not to be well known, and only the literature will carry that legacy forward. And my intention of recording this video is to appreciate that fact as well. And POSIX 1003.1c, also known as POSIX.1c, with further real-time extensions and thread extensions, appeared in 1995 and 1996, and threading support was then built into the operating system. And until lately, C and C++ programs had to rely on operating system specific threading libraries like POSIX threads and so forth, which wasn't that bad though, right? But however, other programming languages brought the concept of threading into the user space, which means into the programming language as well. And of course, with the emergence of a lot of concurrent and parallel programming, that had become an important aspect. So other languages, even C++ including, followed that path as well. So POSIX 1003.1g, known as POSIX 1.g, standardized the networking API, including sockets. I have another slide dedicated for the networking history, networking standard. At the latter part of this particular presentation, you will see that as well. So POSIX 1003.1d appeared in 1999, and 1j in 2000, which included further real-time extensions. And these were all the families of 1003.1 or POSIX.1. But POSIX.2 actually standardized the shell. So I was talking about what was standardized. System interface was standardized, which falls under POSIX.1. The shell was standardized under POSIX.2, as well as the Unix utilities. The shell standardization was based on the features of Korn shell and the Bourne shell, and the Unix utilities, including the command line interface of the C compiler, was standardized under POSIX.2. So what does it mean? So now when you execute a C compiler like CC or GCC, then you provide certain options to the compiler. So those options and what it should mean, all that was standardized, so that if someone else had to create a compiler for a Unix conformance system, they had to use this particular notion of C command line interface for Unix utilities. It was not just limited for the compilers, but other systems as well, like find command, tar command, ar command, cat command, and so forth. So all of those were standardized. So the literature also talks about this other standard that appeared during the 90s as well as during the latter part of 80s, called FIPS. FIPS stands for Federal Information Processing Standard. It was a standard specified by the US government, and the FIPS 151-1 was based on 1988 IEEE POSIX.1 and the draft ANSI standard. So the difference between the FIPS 151-1 standard versus the POSIX.1 was the only difference was whatever POSIX.1 made optional was made required in the FIPS standard, and that's because the FIPS standard was mainly for the US government, and a lot of Unix variants actually supported the FIPS standard. That was because at the time the US government was a major purchaser of computer systems, and having FIPS 151-1 was important to do business with the US government. So the Unix variants were following that as well. So FIPS 151-2 aligns with the ISO 1990 edition of the POSIX.1 standard. But this standard was largely withdrawn by 2000, and that was because they felt it's irrelevant to have another standard, because POSIX and the next one that you will see, the single Unix specification, became very widely adopted. And okay, so next up, so let's talk about this Xopen and the open group companies. So it was a consortium of international group of computer vendors. It produced the Xopen Portability Guide, or XPG. There was a notable first release known as the issue 3, which was also known as the XPG 3 in 1989. XPG 4 in 1992 emerged, and XPG 4 version 2 in 1994. And so this is also a kind of a standardization of Unix operating system. And the Unix System Laboratories was acquired by Novell, and this was again during 1990s, and there had been some legal mishaps between University of California and BSD, and actually various different kinds of entities as well. So I again recommend you to follow my previous video to know about that. But anyway, so they were also working on this standardization, and there were certain delays because of this acquisition and so forth. And anyhow, this XPG 4 version 2 with few other standards called Xopen Cursors issue 4 version 2, Xopen Networking Services issue 4, all together formed another standardization called Single Unix Specification, which became Single Unix Specification version 1, and which was also known as Unix 95 at the time. And it incorporated some of the system file interfaces as well. And the Single Unix Specification version 2 came out in 1997, and it was known as Unix 98 and also as XPG 5. And however, in 1996, Xopen merged with this other entity called Open Software Foundation to form the Open Group, and that's how the Open Group came into light. So you'd have heard much about this popular standardization called the Single Unix Specification version 3 during the early 2000s up to 2010 or so. So many books referred to this version as SUS version 3, SUS v3, and so forth. So it was in 1999 the Open Group and the ISO IEC Joint Technical Committee collaborated in the Austin Texas, and it was called Austin Common Standards Revision Group, and popularly known as Austin Group, to unify the POSIX standard and the single Unix specification, because there were various different standards that came in by 2000. By large, FIPS got withdrawn, and the only two remaining standards were the POSIX standard and the single Unix specification. So they understood the importance of unifying those two as well. So they did that. So the resultant was then known as the POSIX 1003.1-2001, and and it was also known as the single Unix specification version 3. And it contains different sections called the base definitions of header files, terms, and various other definitions, to system interfaces, uh, and shell and other utilities, as well as other rationale for various justifications and so forth. So, and it also includes the Xopen cursors issue 4, which was available in the single Unix specification version 1 as well. So I'm not going to go into defining what cursors is and so forth. It's a very cool command line thing that helps developers to interact applications with the command line. So I recommend you go learn about cursors as well and what it can offer for developers. And end of the day, the Unix standardization offered two levels of conformance called conformance levels, and one is what they call the POSIX conformance levels, which was the baseline interfaces, and it was a subset of what we call as the XSI interface, which means the Xopen system interface conformance. And any operating system that adheres to XSI conformance can call it a Unix 03 system. And so it included everything that POSIX conformance had to have, and some additional interfaces and so forth, right? So, and so those additional interfaces were popularly called XSI extensions, and so they have threads, memory maps, mmaps, memory unmap, DL open API, DL is for dynamic libraries and so forth, and poll, login accounting, and many more. So these are like system programming tasks in the Unix system programming tasks, and if you are into that, you should be knowing these system interface calls and so forth to call yourself a proper system programmer. So I recommend you to learn about that. And then again, single Unix specification didn't stop from the version 4 and version 3 rather. So version 4 came into light at some point, and what actually the version 4 entails is it had more interfaces like the dir fd directory file descriptor, make directory temp, and so forth. And some single Unix specification version 3 optional details became mandatory in the SUS version 4, such as those dynamic library open APIs, POSIX timers, real-time signals, POSIX semaphore APIs, and so forth. And some of the version 3 sections became obsolete in the single Unix specification version 4, including the get time of day, see time calls, and so forth. And some obsolete sections that were in version 3 were removed in single Unix specification version 4. And so that's all about on the standardization of POSIX and single Unix specification and how it converged into one at some point, which is for a good purpose and so forth. So I spoke about the BSD networking. At some point, BSD had a networking API, which was later brought into the common standardization as well. So it warrants a separate discussion. So the TCP IP and sockets API actually originated with the 4.2 BSD in 1983. and they brought in performance improvements in 4.3 BSD in 1986. And then there were a lot of 4.3 BSD releases, a code named Tahoe, which brought in various improvements like fast read transpeed, congestion avoidance, and so forth. And that made to a networking code release called the BSD Networking Software Release 1, which was popularly known as Net 1. And the BSD networking code was at large independent from the AT&T derived Unix code. And AT&T derived Unix code was not 100% open source at the time. It was provided for various different universities, but it didn't license everybody to just use it like the open source that you know today, right? And so that's why the BSD variants and the University of California variants and the AT&T's variants had a legal battle during the 90s. And somehow the BSD code was made independent. It was not reliant on the base Unix code. And the TCP/IP, the kernel implementation, the Unix domain protocols, the socket interface, and the related applications such as the telnet and the FTP client and the servers, all that were made open source. And it was then made available through various FTP servers and so forth for people to download and improve it, learn about it, and so forth. So 4.3 BSD even further improved the networking APIs, networking implementation with fast recovery, TCP header prediction, and so forth. And that release was then called the BSD Networking Software Release 2. That was in 1991 and was also called Net 2. And the BSD releases culminated at 4.4 BSD, and then after it had various different type of BSDs like Open BSD, Free BSD, and so forth, its derivations. And it had multicasting support, the socket multicasting, and that release was known as the Net 3 release. So the networking standards, the socket APIs originated in 4.2 BSD in 1983, and POSIX 1003.12 committee formed to standardize the socket API and the X Open Transport Interface API, which is based on the system-wide transport layer interface. And so they form together. So in parallel, POSIX 1003.1g, also known as X Open Network Specification, I was talking about this in the POSIX section as well, was under development. The first version was known as the XNS issue 4. The XNS issue 5 became part of the single Unix specification version 2, and the XNS issue 5.2 marked XTI, or the Transport Interface APIs, as obsolete and became a basis for SUS version 3. And they kind of became together. So I come into the last part of our discussion on where things culminated with Linux. And yes, Unix is very popular, but for various reasons, Linux kind of overtook the world on the server side, and Linux is extremely popular in various things. So it would be unfair to not talk about Linux and where it stands on the Unix standardization process as well. So the Linux development also aims to conform to POSIX and the single Unix specification standard. However, as per my knowledge and also based on certain literature, no Linux distribution is actually branded as Unix by the open group. And that was purely because of the time and the cost need to obtain this brand for each and every release. Let's say you have a Fedora 38 and 39 comes out and 40 comes out. For each and every release you need to obtain this particular standardization. It's a very cumbersome, costly, time consuming affair, and that's why that was not followed in the Linux world. And also because Linux distributions are managed by both commercial and non-commercial organizations, and it's believed that that particular brand of Unix is difficult to achieve, and also it's not needed and so forth. That's why you don't find Linux as a Unix compliant system on paper though. So it's a Unix like operating system. So between Linux distributions there are also minor differences reminiscent to early years of Unix as well. Now when Unix BSD and the AT&T system 5 Unix had differences likewise between Linux distributions like Fedora, Ubuntu, Mint, SUSE, and so forth. They have minor differences as well, but those are like somewhat on a lesser scale than what Unix had back then. However, so what POSIX and single Unix specification tries to achieve is source code portability. Source code portability is somewhat possible with Linux with minor differences, minor changes, but there is also an effort called the Linux standard base, which is an effort to ensure the compatibility on the binary application to run on any LSB compliant system on a compliant hardware. And that's what the current state of the Unix standardization and how it has affected the Linux, and what level of impact that it had, and the kind of work that the Linux world is doing and so forth. I hope this video had provided you a good understanding of how the history panned out with the standardization, and you cannot talk about the history in a very short video like that in a very comprehensive way. So I really recommend you to read the relevant books if you are interested. And one of the books that I referred was the Linux Programming Interface, and also Advanced Programming in the Unix Environment by the popular book by the Richard Stevens, late Richard Stevens, and I recommend you to follow and read those books if you're a system programmer particularly. And I hope to see you in another video like this with more information regarding how-tos and history of computing and so forth. Please subscribe to my channel and to learn more about this and to get notifications. And see you next time.